Welcome to this training on conceptual data modeling practices. In this session, the objective is not to discuss technology first. The objective is to learn how to describe business reality in a structured way so that people, systems, and now AI can reason on the same foundation. Conceptual data modeling is therefore a language of clarity. It allows us to move from vague discussions to explicit business concepts, explicit relationships, and explicit meaning. Throughout this training, I will progressively show you how to think before you model and how to model before you automate. That sequence is essential. If the conceptual layer is weak, everything built on top of it becomes fragile. At the conceptual level, we represent business knowledge in natural language. That means we describe the business with concepts that stakeholders can understand and discuss. We also aim for genericity because the model must scale over time and support future extensions. At this stage, we exclude technical details such as foreign keys, timestamp, indexes, or any system-generated mechanisms. We also do not model workflows, reporting structures, or algorithms there. Why? Because conceptual modeling is about the semantics of the business, not about implementation choices. We are trying to answer a very simple question: what exists in the business world and how are those things related? Conceptual modeling is useful because it creates the bridge between business thinking and operational systems. Thanks to no-code and low-code platforms, the distance between a model and a working database has become much shorter. In other words, a good conceptual model can now be translated more quickly into an operational repository. This is especially important for AI automations, because AI requires a reliable and structured data foundation. That is why the Operational Data Store, or ODS, becomes so important. The ODS is not just a database. It is a controlled representation of business reality structured in a way that makes automation and reasoning possible. The business data model represents most of the enterprise ontology. In this training, I suggest thinking of it as roughly 90% of the ontology. The remaining 10% is added when we place that model into an enterprise knowledge graph, or EKG, and enrich it with heuristics and graph-oriented reasoning. This is an important idea. The conceptual model is not a secondary artifact. It is the structural core of the ontology. The graph does not replace it. The graph extends it. So when we invest in conceptual modeling, we are already building the main body of the enterprise semantic layer. The ODS and the EKG share the same business glossary and the same structural taxonomy, including the inheritance hierarchy between concepts. That common semantic foundation is essential. However, the two repositories do not play exactly the same role. The ODS is based on a formal data model. It is designed for control and consistent storage. The EKG, by contrast, can represent information as nodes and relationships. It can incorporate the relationships already described in the business ERD, but it can also absorb knowledge from less structured sources. This distinction matters. The ODS is the place where structure is stabilized. The EKG is the place where structure can be extended, connected, and explored more dynamically. In summary, mastering business ERD modeling together with the business glossary is fundamental, because this is what creates a shared ontology between the ODS and the EKG. This is directly justified by the need to provide AI with data and knowledge that are as unambiguous as possible. On top of that, a strong semantic layer allows us to use graph-based retrieval, native graph queries, and graph vector combinations more effectively. Of course, this does not remove the need for classic software controls such as rules, validation, or pre- and post-conditions. But it radically improves the quality of the knowledge environment on which AI operates. A conceptual model should start from a description of the company's activity, written as narrative use cases, not as workflows. This is very important discipline. The purpose is not to document the organization chart or the BPMN of the moment. The purpose is to capture the business meaning of what the company does. To support that effort, we can rely on standard modeling patterns inspired by ERP/CRM on the company's own industry sector. Those patterns help, but they should never replace thoughtful description. The narrative remains essential because it is where concept, relationships, and business distinctions first appear in language. Even if there are no rigid formal rules, some practices are extremely valuable. First, high-writing quality matters. A conceptual model begins with the ability to describe reality well. Second, the objective is to capture the intrinsic value of the DNA of the business concept, while reducing the noise of organizational descriptions, such as workflow or BPM language. In the meta mindset, the focus should be on motion, what the business fundamentally does. Each use case should stay concise, ideally 2 or 3 pages, and rarely more than 5. The description must be short enough to stay readable, but precise enough to allow extraction of the ontology of the scope, concept, key data element, and the relationships between them. For many years, a unified database looked like a nice-to-have for many companies. Today with AI, it has become a must-have. Why? Because AI amplifies both clarity and confusion. If the company has a coherent semantic structure, AI becomes much more powerful. If the company has fragmented concept and ambiguous data, AI amplifies disorder. Another major shift is that complexity no longer has the same impact on modeling workload as before. Historically, complexity meant long, manual, laborious work to establish the business glossary and the model. Now, AI can accelerate part of that work. On no-code, low-code, platforms accelerate the transition from model to database. But the need for conceptual discipline has not disappeared. It has become even more strategic. This training uses visual paradigm as a modeling tool, but the method itself is independent of the tool. The legal notice on this slide simply clarifies that the model presented here are original work created by the author, while visual paradigm remains the property of its editor. This distinction is useful because it reminds us of something important. Methodology comes first, tooling comes second. A tool can help you draw, organize, and maintain models, but no tool can replace the conceptual discipline required to produce a meaningful semantic layer. In this context, ERD, UML class diagram, and data model can be treated as equivalent views of the same structural reality. Likewise, a class can be read as a table, and a relation can be read as an association. Of course, depending on the audience, each term may carry a slightly different tradition. But for this training, the point is not terminological purity. The point is alignment. We want everyone to understand that we are dealing with business concept and relationships between them, whatever diagramming tradition they come from. The engineering process begins with the business data model. This is where the concept and business relationships are defined. Then we move on to the logical data model, where those concepts are prepared for implementation. From there, the structure can be translated into an operational data store. In parallel, or afterward, parts of that semantic structure can also be expressed in RDF or WAL and connected into an enterprise knowledge graph. So this slide is important because it shows continuity. Conceptual modeling is not an isolated intellectual exercise. It is the first structural step in a chain that leads to operational systems and AI-ready knowledge repositories. The diagram navigator gives a flat list of diagrams created in the project. That can be convenient when you want quick access to a specific artifact. But it is not the best approach for maintaining a structured repository over time. The Model Explorer, by contrast, organizes all model elements hierarchically. Classes, attributes, associations, packages, and subpackages. That hierarchy is much closer to how the knowledge repository should be maintained. So even at the tooling level, there is already a lesson here. Prefer organization that reflects semantic structure, not just convenience of access. The diagram navigator is useful when you want a quick entry point to a specific diagram. It is fast, direct, and practical for local navigation. But it is not ideal for maintaining a well-organized repository. Why? Because it emphasizes drawings rather than semantic ownership. Over time, that can encourage an ad hoc modeling styles where diagrams accumulate without a strong structural backbone. So it is useful, but it should not become the primary mental model for the repository. The Model Explorer is recommended for projects where the goal is to build a long-term structured repository rather than a collection of ad hoc drawings. It organizes packages, class diagrams, tables, and relationships in a hierarchy that can be maintained coherently over time. This is much more aligned with the vision of a semantic layer. We are not creating isolated drawing. We are building a reusable knowledge asset. The Model Explorer better supports that ambition because it makes structure, ownership, and reuse more visible. When a table appears in several packages, we should think in terms of reuse, not copy. That is exactly what this slide illustrates. Drag and drop in this context is not about duplicating a concept. It is about reusing the same concept where it is needed. This is essential because semantic duplication is dangerous. The moment one concept is copied in several places, it can evolve differently and create ambiguity. Reuse protects consistency. It ensures that the same business concept remains the same wherever it appears. A clear naming convention should reflect the package location of the table owner. This helps everyone understand where the concept primarily belongs, even when it is reused elsewhere. That may sound like a small repository detail, but it has strong semantic value. Good naming reduces ambiguity, clarifies responsibility, and makes the model more self-explanatory. In a large repository, this becomes a major factor of maintainability. Packages should not be determined arbitrarily. They should emerge from the business concept themselves. In other words, packaging is a semantic act, not a cosmetic one. We create a package when we identify a coherent subset of the business model that deserves its own structural space. This is why good conceptual thinking must come before repository organization. Packages are not a folder invented after the fact. They are a way to reflect conceptual ownership and meaningful grouping in the model. A main table represents a business concept of strong semantic significance. It acts as the anchor of a package and is typically surrounded by no more than about 20 tables. That threshold is practical rather than absolute, but it helps maintain readability. The slide also reminds us of the older push notion of category, which in modern UML is usually represented by a package. The important idea is that a package is not just a container, it is a structural home for a major concept, and that major concept is explicit through the main table. Each package contains one and only one main table. This rule is extremely useful because it forces conceptual clarity. If you cannot identify the main table of a package, the package is probably not well defined. Conversely, if several tables seem equally central, then you may be mixing several business concepts in the same package. This rule therefore acts as a quality control mechanism. It forces the modeler to be explicit about the semantic center of each package. If we take a geography package, the main table might be country. If we take an address package, the main table might be address. These samples helps illustrate how packages are grounded in distinct semantic centers. The slide also introduces the idea of a connection point between data models. This matters because packages are not isolated worlds. They connect. But when they connect, each still keeps its own semantic anchor. That is what preserves clarity across the larger repository. When a main table from another package is reused, its stereotype is not displayed. This keeps the diagram lighter and avoids visual overload. The important thing is that a reuse is still semantically understood, even if every visual marker is not repeated. Here again, the principle is clarity. The repository must remain readable without losing structural meaning. When a data model contains tables that are isolated from the rest of the design, this usually indicates that several business concepts are present and that multiple main tables may exist. In other words, isolation is often a symptom of poor packaging. It suggests that the model is trying to hold together concepts that should in fact be separated. This is why layout and semantic analysis go together. The diagram can reveal structural problems if we know how to read it. When a data model has too many tables, for example more than around 20, it should usually be divided into several packages. Again, this is not just about visual comfort. A package with too many tables often indicates that several important business concepts are coexisting in the same space. Splitting the package helps recover semantic focus. It makes the model easier to understand, easier to maintain, and easier to evolve. At the conceptual level, business attributes should represent business meaning. That means we should always include the business code when one exists, such as an SKU, a customer code, or a contract number. By contrast, we should not include technical identifiers such as database ID, UUID, or system-generated keys. Those belong to later modeling layers. This slide also recommends using a tag attribute as a mnemonic when a long business name needs a concise reference. The overall objective is simple. The model should communicate clear semantics to business stakeholders without unnecessary technical complexity. The name of tables, key attributes, and relationships should be defined in the business glossary. The glossary is therefore not a side document. It is the foundation of the ontology. If the glossary is weak, naming becomes arbitrary. If naming becomes arbitrary, ambiguity spreads. And once ambiguity spreads, data, automation, and AI all suffer. So this slide marks an essential principle. Naming discipline is not cosmetic. It is one of the main mechanisms by which semantic quality is protected. Spatial layout matters. The diagram should be centered in the window by default. Crossing line should be minimized. Scrolling should not be forced unnecessarily. These might look like presentation concern, but in reality they affect comprehension. A poorly arranged model increases cognitive load and hides structure. A well-arranged model allows relationship and grouping to appear more naturally. Modeling is not only about correctness, it is also about making meaning visible. Reorganizing the presentation of tables, relationships, and packages is not a superficial activity. It is part of making the model understandable. The underlying structure may stay the same, but the readability can improve dramatically. That matters in training, in collaboration, and in governance. If people cannot easily read a model, they will not use it as a shared reference. When you model an association A-B, the multiplicity shown near class E indicates how many instances of E can be linked to one instance of B. The key reading rule is therefore simple. Always read multiplicity from the opposite side. This is where many people make mistakes, so it is worth slowing down. In this example shows here, one machine capacity can be used by 0 to many machines, while one machine is associated with one and only one machine capacity. This is the correct reading, and this rule is not arbitrary. It is aligned with the UML specification of OMG. If your audience truly understands this slide, they will avoid a very common source of structural misunderstanding. The name of the association can either be placed in the middle of the connection, allowing two possible directions of reading, or at the edge of the table where the reading begins. The practical objective is always the same: make the business statement easy to read and unambiguous. For example, if the association is written near the machine side, it should be readable as a machine book's maintenance schedule. It may seem like a notation detail, but it has real pedagogical value. Good association naming turns the diagram into readable business language. This slide introduces three important forms: qualifier attribute, association class, and ternary relation. Each one addresses a different level of modeling complexity. The qualifier adds precision to the relationship. The association class allows the relationship itself to carry attributes, and the ternary relation captures a business fact that truly involves three concepts at the same time. In this example, a party such as ABC Company is linked to a site such as French headquarters with additional contextual elements like location, nature, and address language. This is exactly the kind of situation where a simple binary relation is often not enough. The qualifier attribute helps disambiguate the relationship, while the association class provides a place to all attributes that belong to the relationship itself. This is where conceptual modeling becomes powerful. It allows us to represent business nuance without collapsing everything into a single overloaded object. A site is not just a postal address. It is a name place with business meaning. It groups one or multiple addresses and provides a semantic label. This is why we must distinguish site from party. A party is an actor, legal entity, or person that can play roles such as customer, supplier, or employee. A site, by contrast, is a location owned or used by a party. It has no legal autonomy on its own. So the distinction can be summarized simply. Party is the who, site is the where. Making such distinction explicit is one of the main values of conceptual modeling. Each record in an association class corresponds to one unique pair of records from the two related classes. This means the relationship is not treated as a simple line anymore. It becomes a first-class business object. This is exactly what we need when the relationship itself has attributes, constraints, date, statuses, or business meaning. Association classes are therefore a key technique for avoiding oversimplification. A ternary association captures a fact that simultaneously involves three classes. The important point is that this is not just three binary links drawn together. It is one business relationship with three participants. If we break it incorrectly into binary pieces, we can lose meanings or introduce false interpretations. This is why ternary relations should be used when the business fact truly depends on the combination of the three concepts. Here the attributes are separated cleanly into their own class. This gives several benefits. The association class can be referenced by another relationships, and it can be reused across multiple triples. For example, across different combinations of business plan detail, client, and product. This is a strong modeling pattern because it preserves semantic precision while keeping the structure extensible. This slide illustrates a simple but powerful principle. If a sales target is broken down into allocation, then both the target and the allocation must reference the same finished product. Otherwise, the structure becomes inconsistent. Referential integrity therefore protects logical coherence across the model. Even at the conceptual stage, it is useful to express such rules because they reveal what must remain aligned in the business semantics. A derived attribute is calculated by the system. It is not a primary business fact captured at the conceptual level. If a table consists only of derived attributes, then it usually corresponds to a consolidation or reporting need rather than a core business concept. This is an important warning sign. Conceptual modeling should focus on intrinsic business meaning. If a structure exists only to aggregate or compute, it may belong to another layer. Inheritance is useful when we want to cover an existing need while also anticipating future requirements. It allows us to define a parent concept and specialized child concepts in a clean structural way. Done well, inheritance introduces genericity without losing business meaning. Done badly, it introduces confusion and artificial abstraction. So the key is to use it only when the semantic relationship is truly one of generalization and specialization. Use inheritance only when the parent-child link is unique. If that uniqueness does not hold, it is often better to model the structure with a many-to-many relationship. This rule is important because inheritance is frequently overused. Modelers sometimes use it to express reuse or category membership when it is not the right semantic mechanisms. A clean inheritance structure should express a true is-a relationship, not just a convenient grouping. Multiple inheritance can be enforced when the specialized tables contain specific attributes that justify belonging to several parent structures. However, this should be handled with great care. The more inheritance paths we introduce, the greater the complexity. So multiple inheritance is not forbidden, but it must be justified by strong semantic reason and keep understandable. A complex type is used to group multiple related attributes into a reusable structure. This is useful when the grouped attribute forms a meaningful unit that appears in several places, but does not necessarily deserve the full status of an independent business concept. The slide also mentions the idea of a multi-valued attribute, which reminds us that some business properties can naturally hold more than one value. Again, the goal is faithful representation of business reality without unnecessary duplication. When model readability matters, we can show complex type usage with a use dependency. This helps a reader understand that the complex type is being reused rather than redefined. It is a small notation choice, but it improves clarity and reuse awareness in the diagram. General reference tables should be grouped in a dedicated package. This applies to share concepts such as countries, currency, calendar, standard categories, or other reusable codes. Centralizing them helps maintain consistency across the model. It also makes governance easier because these references often support many domains at once. The name of each table and each attribute must fully convey its semantic and avoid ambiguity. If a label can be understood in two different ways, then it is not good enough. This may sound demanding, but it is essential. Ambiguous naming is one of the fastest ways to degrade the semantic layer. Clear naming, by contrast, makes the model self-explanatory and much easier to align with business stakeholders and AI systems alike. Tags can be used to enhance expressiveness of attributes. They provide a compact mnemonic while preserving the longer semantic meaning when needed. Used properly, tags make diagram easier to read without sacrificing clarity. They are therefore practical complement to strong naming discipline. Workflow should not dominate the conceptual model. However, a workflow complex type can be used as an anchor when such a notion is required structurally. The key is to avoid letting process logic overwhelm business semantics. The conceptual model should remain centered on what the business is, not on every procedural detail on how work happens. Status represents the business states that a record may take over time, independent of process design. For example, an object can move from created to reviewed to approved. This is a lifecycle notion, not a full workflow description. That distinction matters. Status belongs more naturally in conceptual modeling because it expresses a business state, while workflow usually expresses procedural orchestration. We have covered the main principles of conceptual data modeling: business description, glossary discipline, package structure, main tables, naming, association, inheritance, complex types, reference data, workflow boundaries, and status. Across all these topics, one central idea remains constant. Conceptual modeling is about structuring meaning before structuring technology. That is why it matters so much in the age of AI. If the meaning is weak, the system becomes brittle. If the meaning is strong, automation, analytics, and AI all gain a much more durable foundation. Thank you for following this training.